Bright Tuty. Every student matters.
Are like fractions, unlike fractions. Okay, so this is all we are going to cover in this lesson. So here, let's start with like fractions and unlike fractions. So here, starting with the definition, it says fractions with same denominators are called like fractions. So see in the image that you see, here we are given a box which is divided into 4 equal parts. Is that right? So how do we write this fraction? We write it as 1 over 4. Look at the second image. Here, do you see that we have got a box with 4 divisions out of which 2 are shaded? So we have 2 over 4. In the third one, we have got the same box which is divided into 4 parts out of which 3 are shaded. So we write the fraction as 3 over 4. So what do we notice here? We see that in all these 3 given images, we have the same denominator. Here, at the number sitting at the bottom, it is 4, right? So clearly, we have the same denominators in all these 3 cases. So every time you see fractions which are having the same denominators, we call them like fractions, okay? Don't look at the numerator part, just consider the denominator part, and if you see that the denominators are same, we call them like fractions, okay? Now, what about those fractions where we don't see same denominators? Such fractions, simple, it's opposite of like, it is unlike fractions. Like here it is written, fractions which have different denominators are known as unlike fractions. So you can see the image. In the first circle we see 2 divisions. So here at the denominator we got a 2. In the second image we can clearly see we have got 3 divisions in the circle. So this denominator is 3. And in the last one it is 4 parts are seen out of whole. So 4 is the denominator. So clearly we got different denominators, and thus these kind of fractions are unlike fractions. I hope this is very much clear because this is going to help us in this lesson further. Now let us see how we are going to compare these kind of fractions. Okay, so we are just going to look at the images and then we will compare them. So clearly we are going to visualize how these fractions look like, and then we'll see whether they are equal or not, or whether they are, which one is bigger, which one is smaller. So starting with the first image, which is already done for you. So look in that, what we are given is that here the first image represents 1 over 2. Is that right? So 1 over 2 is basically half, and 1 over 3 is 1/3. So out of the second circle we have got 3 divisions, only one part is shaded. So don't look at these fractions here for once, just look at the image. Do you see that here this is the bigger portion of the circle and this is a smaller part? Or you can imagine this, suppose you are eating a pizza. So if you are dividing the same pizza among 2 people, and if you are dividing the same pizza among 3 people equally, so which one do you think will have more amount of pizza? The one which is divided into 2 people or the one which is divided among 3 people? Obviously, the one which is divided into 2 people, right? So thus, 1 over 2 is bigger than 1 over 3. Now let's do the next one. It is 2 over 4 and 3 over 4. So let us do one thing. Let us shade this part, okay? We are going to shade 2 parts out of 4. So 2 parts, I'll just use the other thing. Okay. So if I'm shading 2 parts out of 4, it is exactly half. Is that right? Now let me shade 3 parts out of 4. Shading 3 parts out of 4, what do you see? Obviously, the second image is definitely bigger. This portion is bigger. Again, you can imagine, if out of 4 parts you are given 2 parts of a pizza, or out of 4 parts you are given 3 parts of the pizza, in which case you are having the more favorable amount of pizza? Obviously 3 over 4, right? Now the next one says it is 2 over 4. So let us mark 2 over 4. It's again half. And it is 2 over 3. So see, when I'm shading 2 parts out of 3, Which shade do you see has covered more area on the circle? This second image, right? So this is the bigger fraction. Now moving to the next one. Here it is 2 over 4 again. So let's shade 2 parts out of the 4. And here we have got 4 parts out of 8. So 1, 2, 3 and 4. Okay, so what do you notice now? Do you see that here 2 over 4 and 4 over 8, they are basically equal. We are shading just the half in both of these images, right? Now let's do the next one. It says 1 out of the 2. I'm sorry. Okay, so it says 1 out of the 2. So we have shaded 1 part out of the 2 parts. And here it says 2 out of 4. So now again, what do we see? In both these images, we clearly see that we have shaded equal part. So they are equal fractions. Coming to the next one, the last one here. It says 3 parts out of the 4. So let's shade 3 parts out of the 4. The next one says 4 parts out of 5. So here out of 5, let's shade 4 parts. Clearly look into the image. What do you see? Which part is bigger? Is 3 over 4 bigger, or is it 4 over 5 that is bigger? I hope you can notice that 4 over 5 is bigger compared to 3 over, I'm sorry, not equal. 4 over 5 is bigger, right? So here what we have done, we have learned how to compare the fractions using the images, okay? So now make sure that when you have such kind of images, you will always notice that the given fractions, they're usually small, because it's not easy for you to draw such images and then you can compare them. It's very troublesome at times, and especially if the fractions are bigger. Now let us see what method can we use if we have got different bigger fractions rather than just working with the simple ones, okay? So here it says we often come across situations where we need to compare fractions. There is a systematic procedure available for comparing fractions. Okay, we are going to follow a particular procedure with which we can compare any type of fractions, not just the simple type of fractions where you can just draw and shade and get the comparison done. No. What about those when you are comparing the numbers which are very big? You cannot draw them, right? So let's see how it's done. This particular systematic procedure that we are going to follow, it's basically divided into 2 parts. One, that when you are comparing like fractions and when you are comparing unlike fractions. Okay, comparing like fractions and comparing unlike fractions. Make sure that you do remember what like fractions are and what unlike fractions are. Like fractions are those where you see the denominators same, right? And unlike are those where the denominators, they are all different. Okay, so I'm just writing they are not same. So keep this in mind. This is going to help us in every question that we are going to follow. Comparing like fractions. So here we are going to start from comparing the like fractions. Like fractions are the fractions with the same denominator. So we have to compare them with the numerator only. The fraction with greater numerator is greater. So here let's read it again and understand it well with the help of the image that is given. It says like fractions are the fractions with same denominator. We already know what this particular statement means, right? So whenever you see like fractions, say 1 over 4, 2 over 4, 3 over 4, 8 over 4, whatever you see that every time you notice the denominators, they're just same. So what we do, instead of looking at the denominators, we are just going to consider the numerator part. We are just going to look the numbers sitting on the top in the fraction. Okay. And this is where you see how we are going to compare. The fraction with greater numerator is greater. Simple. Let's see this with the help of an example here. Here we are given a figure. We are given that both these particular images that you see, they are divided into 8 equal parts. So these small boxes that you see, they are basically 8 equal parts. So the fraction with 7 shaded parts is greater than the 5 shaded part. Is that right? So here we were comparing 5 over 8 and 7 over 8. So clearly we got 8 as the denominator for both these fractions. So we are not going to consider the denominator part. We'll just look at the numerator parts. At the numerator, here we have got 5. Here we have got 7. What's bigger? Is 7 bigger or is 5 bigger? Obviously you know the answer. 7 is bigger. So what do we do when we see like fractions? Because they have got the same denominator, we just look at the numerators and we compare them and say who's bigger. I hope this is clear. Let's make another, let's learn something about more when we are working with unlike fractions. We just worked with the like fractions. Now let's work with unlike fractions. Working with like fractions is very simple. Okay, it's very easy to remember what you will do if you see the same denominators. You just compare the numerators. What the tricky parts come is when you work with the unlike fractions. Okay, it says the fractions with different denominators are called unlike fractions. I hope you know this. Now, unlike fractions can be of different type. The first type, unlike fractions which are having the same numerator. Okay, so unlike fractions are those which have got different denominators. Now we are further dividing it into two parts. One with same numerator and the other one with different numerator. Okay, so for example, if I have got here, it's the example given to you. See 3 over 4 and 3 over 8. See, because the denominators are different. One is 4 and one is 8. So they are unlike fractions, right? But what do we notice? We notice that the numerators, they are same. So is there any way, a shortcut method by which we can compare them? Yes, there is. If we have to compare the fractions with different denominators but same numerators, we have to compare the denominators only. Like we just worked here, when you were having same denominators, you only compare the numerators. Now when you have got same numerators, you just compare the denominators. Now what are we going to do? See, listen to this very carefully. The fraction with same denominator is greater than the other. Just the opposite of what you just learned, right? Here, when we were looking at the numerators, the numerator which was bigger was bigger. In the unlike fractions, what is the difference? The denominator which is smaller is basically bigger. Okay, so keep this in your mind when you were working with like fractions where the denominators were same but numerators were different. So the bigger one was bigger. Now unlike fractions are totally opposite. You have got different denominators in unlike fractions, and if suppose you have the same numerator, what do? You don't compare the numerators, you just compare the denominators. And the one which is smaller is basically the bigger fraction. So look here, they have shown you how. See, in the image, it is shown that this particular box, it has got 4 divisions, right? It is divided into 4 equal parts. The same block is divided into 8 equal parts. If we are selecting 3 parts out of 4, so this much part is shaded, and if we are shading 3 parts out of 8, so just this small part we can see is shaded. So clearly, do you see that 3 over 4 is the bigger fraction? Okay, or you can imagine that like this. Suppose if you have got a pizza and you are dividing it into 4 equal parts. Okay, so what do you think? If you have got 3 people and you got 4 things that has to be divided, so then you are going to get a greater fraction. Or if it is like you are having something like it is divided into 8 equal parts and you are just getting 3 out of it, obviously where you are just dividing it into 4, there you will get a greater fraction. I'll just draw it here. Say this is a pizza, and if you are dividing it into 4 parts, here the denominator is 4, right? So out of these 4, say you are getting all these 3 parts. Okay, you are getting all this. So imagine this is a bigger part, or say the same pizza. Oh, I'm so sorry, my bad. Yeah, so imagine again, so you have the same pizza. Now this pizza, say it is divided into, instead of 4, it is divided into 8 parts. I hope I'll do it correct. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So I'm sorry these parts don't look equal, but just imagine that they are equal. So here out of these 8, suppose now you are also getting 3. I'll just shade them so that you can have a better picture. Okay. So out of 8, you are getting 3 parts. So which portion of the pizza would you like to have? Would you like to share the pizza in the first image or the second image? Clearly, if you are a pizza fan, you will definitely go for the first image. I hope now it is getting clear how we are comparing unlike fractions with same numerator. Let us understand them better by doing some questions. I'm sure you will understand it better by this. Here it says arrange the following in ascending order. Ascending order is that we are going to start from the smaller number and we'll go till the bigger one. Okay. So here look what the numbers are. It is 1 over 12, 1 over 23, 1 over 5, 1 over 7, 1 over 50, 1 over 9, 1 over 17. So every time you notice that the numerator is 1, so all the numerators that are given to us in these fractions, they are all same. They are just 1. So what do? If we have got, and clearly what I need you to notice is that every time you see that the denominators are different. So let us write what these kind of fractions are. These are unlike fractions. Am I right? These are unlike fractions. Why? Because they have got different denominators. Now, what special thing they have got? They have got same numerators. They have got same numerators. So keeping these two things in our mind, let us arrange these numbers. So we just learned that when we have got unlike fractions with the same numerators, we compare just the denominators, and the one which is smaller is basically the bigger. Okay. So here, which number do you see? Let's just write 1, 2, 3, 4, 5, 6, 7. So we have got 1 over something, 1 over something, 1 over something, 1 over something. So 1, 2, 3, 4, 5, 6 and 7. Okay, so I have just written the numerator part of all these 7 fractions. I need to fill the denominators. Now, remember this, the one which is having the smallest denominator is the biggest fraction. So let us see which one has got the smallest one. So here 1 over 5. 5 is the smallest denominator. So imagine if you are dividing one pizza into 5 people, then what particular slice will look like, and imagine this one pizza divided into 50 people, what will be the size of the pizza. So just imagine these kind of fractions in your head into pictorially. If you are imagining them, this will really help you, right? So now here let's start with the smallest one. So smallest fraction is 1 over 50. Why? Because 50 is the biggest number, so the slice will be the smallest of my pizza. Now after 50, I see 23 as the biggest number. Okay, so 1 over 23 will be the smallest fraction that will come after 50, 1 over 50. Now which number do we have after 23 is 17. Then we have got after 17 is 12. Then what do we have? We have got a 9. Then we have got a 7. And then we have got a 5. So do you notice 1 over 50 where the denominator was the biggest is basically the smallest fraction, and 1 over 5 where the denominator is the smallest is basically the biggest fraction. I hope this is clear. Now let us look the next one here. What do we notice here is that again we have got all the numerators equal. So we are going to just compare the denominators, right? So 1, 2, 3, 4, 5, 6, 7 again. So I'll just write 3 at the numerators just to make my work a little simple. 1, 2, 3, 4, 5, 6 and 7. So we have got total 7 numbers that needs to be filled. Again, keeping in our mind, the denominator, which is the biggest, is basically the smallest fraction. So which number do you see is the biggest? I think 3 over 17. 17 is the biggest number. So it is basically the smallest fraction. Then we have got 13, that is biggest. Then we have got 11. Then we have got 7. Then we have got 5. Then we have got 4. Then we have got a 2. So this is how we have arranged these fractions into ascending order. That is from the smallest to the biggest. Now let's look at the other type of comparison of the fractions where we are comparing unlike fractions, but here the numerators are also different. Okay. Firstly, we learned how to compare the like fractions. It was very simple. Like fractions have got different numerators, but the denominators were same. So we just compare the numerators. So whichever numerator was bigger, we call it the bigger fraction. Then came into picture unlike fractions. Unlike fractions have got different denominators. There also we divided it into two cases. One where the numerators were same, right? So what do? We just keep the numerators as it is and we just compare the denominators. And the denominator which is bigger, we call it the smaller fraction. Now we are working with the next condition that here the fractions are unlike. That means the denominators are different. Also what is different is the numerator. So these are totally random fractions that will be put in front of you. It says let us compare by converting unlike fractions to like fractions. So the question is 4 over 5 and 5 over 6. Okay. So 4 over 5 and 5 over 6. Okay. Now can you write the equivalent fraction to 4 over 5? Let me just multiply. I'll just write some equivalent fractions to 4 over 5 by multiplying each of them by 2. Okay, I'm just multiplying the numerator and denominator by 2 for now. So this will be 8, this will be 10. I'll just write another equivalent fraction. I'm here multiplying 4 and 8 both by 3. So 4 times 3 is 12 and 5 times 3 is 15. Let me write another one. Let me multiply 4 and 5 by 4. So 4 times 4 is 16 and 4 times 5 is 20. Let me write some more. I'm going to multiply 4 and 5, these numerator and denominator. Let me multiply it by 5 each. So here it will be 20 over 25. Now I'm going to multiply the numerator and denominator by 6. Okay. So here it will be 24. And here it will be 30. Okay. So here obviously we can just keep on working in the similar way. We can just keep on writing the equivalent fractions. Let's do the same with the other fraction as well. 5 over 6. Multiplying numerator and denominator by 2. It will give 10 over 12. Let me multiply the numerator and denominator by 3. It will give 5 over 18. Multiplying numerator and denominator by 4. It will give 20 over 24. Multiplying the numerator and denominator by 6. not 6, 5. So it will be 25 over 30. Stop here. Though you can keep on working for further equivalent fractions, but here I am asking you to stop for a reason. Why? What I notice is that here 24 over 30 and here 25 over 30, they are basically the like fractions as they have got the same denominator sitting at the bottom. Is that right? These two fractions that I have shaded so well, so these two fractions are basically like fractions and also they are equivalent fractions to the given fractions, that is 4 over 5 and 5 over 6. Is this clear? What equivalent fraction? To 4 over 5 we have written, to this particular number 4 over 5 we have written the equivalent fraction as 24 over 30. Okay, this is the equivalent fraction. And to the fraction 5 over 6 we have got the equivalent fraction 25 over 30. Right. So these two fractions we have made. Now just look at 24 over 30 and 25 over 30. Which one do you think is bigger? Out of 30 chocolates, if you get 24, or out of 30 chocolates you get 25, where do you have more number of chocolates? Obviously, when you have got out of 30, you get 25 chocolates. So with this, what we got? We got that 4 over 5, it is smaller than 5 over 6. So we have basically compared this particular fraction, okay, by working out the equivalent fractions here for the unlike fractions where the numerators were different, denominators were different. Okay, so this is one method to do this. What did we do? We kept on writing the equivalent fractions till we get to a particular fraction which is having the same denominator for both the fractions. I hope we are going to make this even more clear when we discuss some more examples. Look at this example here. It is saying that compare 6 over 7 and 3 over 5. Okay. So it says that the product of 5 and 7 is 35. So what are we going to do? With 6 over 7, we are going to multiply 5 so that we get 35 at the denominator. And for 3 over 5, we multiply it by 7 so that we get 35 as the denominator. And simply, these are the equivalent fractions, and on comparing, we can see 35 over 30 is the bigger compared to 21 over 35. Let us discuss this again in order to make why we have used 5 over here and why we have used 7 over here. Now, we just learned that we are basically keep on working for the equivalent fractions to get to the answer. Here, the slide just we worked with, we were multiplying the numbers with 2, 3, 4 so that we get the equivalent fractions till we reach to a point where we see the denominators are same. So what are we basically doing? We are basically finding the LCM of the denominators. Let us write down what is the LCM of 7 and 5. Clearly, what we see that 7 and 5, they have got 7 goes into 7 and 5 goes into 5. So they are basically the prime numbers that don't have any common factor. So the LCM comes out to be 7 times 5, that is 35. Okay. Now, can you think how can you multiply 6 over 7 with something so that you get 35 as the denominator? Do you remember we learned in the equivalent fractions? In the previous video, we worked with equivalent fractions. So these kind of questions were there. We were asked to find what to be multiplied so that this particular numerator you get or this particular denominator you can get. So here it's saying that you have got 6 over 7. What number can you multiply it with so that you get 35 as the denominator? So the answer is, if I'm going to multiply 7 by 5, I'll get 35 as the denominator. I do the same with the numerator and get the answer as 30 over 35. I'll do the same thing with the other fraction. What? It says we have got 3 over 5. So 3 over 5, if we multiply it by some number so that we get denominator 35. So what number should it be? It needs to be 7. We do the same with the numerator and this gives the answer 21. So now what do you think? Is 30 over 35 is bigger, or is it 21 by 35? Imagine if out of 35 marks you get 30. Then are you scoring better? Or out of 35 you are scoring 21. Then are you scoring better? Obviously, when you are scoring 30 out of 35, that's when you are scoring even better. I hope you have got this question even better. So now, let's move to this question. Let us see how we can compare these two fractions. Here it is 5 over 6 and here it is 13 over 15. Rather than working for all the fractions that are equivalent, let us just simply find what is the LCM for 6 and 15. Let us do it here formally. This is a 6, this is a 15. So 6 and 15, they both are divisible by 3. Is that right? So 3 goes into 6 2 times and 3 goes into 15 5 times. Now 2 goes into 2 once and 5 goes into 5 once. So what do you see? What is the LCM of 6 and 15? LCM is 3 times 2 times 5. and the answer is 30. So what is the LCM? 30. Now, what can you multiply by 6 in order to get the denominator 30? Okay. And similarly, what can you multiply by 15 in order to get the denominator 30? What can we do? 6 times 5 is 30. So we do the same with the numerator. And here 15 times 2 is 30. So we do the same with the numerator. 5 times 5 is 25 and 13 times 2 is 26. Now simply compare. Do you think 25 over 30 is bigger or 26 over 30 is bigger? The answer is 26 over 30 is bigger. And what fraction is 26 over 30? It is basically 13 over 15. So let us write down what is bigger. Is 5 over 6 bigger or is 13 over 15 bigger? By working out the equivalent fractions, we have just calculated that 13 over 15 is the bigger fraction. I hope this makes sense.